It's Frantone time again. So I got a pedal in for repair. It's not very often that I get a pedal in for repair. If you know anything about Frantone, my pedal company, always used top-notch parts, but they're not invincible. Even though I build them like a tank, people do find ways to blow them up or whatever. And I got one in for repair. I think someone had gotten it off of eBay or something and gotten it, as is. Looks like it's had some hard times. So I just wanted to replace some parts and go over sort of a little bit of troubleshooting for basic issues. Stuff like that. Just a quick little video. So what do we got today? This is classic Fuzz. This is one of the original runs. It's from 2003. The first run of the classic Fuzz that I did, it was in a green. I called it Cosmonaut Green with the red knobs, but later changed to beige because I went to epoxy paint. And this was the epoxy version from 2003. And some parts have been changed out. It looks like it had had some issues. Often what happens with a lot of pedals that I get back is people blow them up either by plugging like a 24 or 30 volt power supply into them, or they put in an adapter with a reverse polarity. I have my own sort of very specific sort of Frantone trademark crowbar in there to protect my pedals. Basically, I started putting them in a form of crowbar, which is a... Fran, what the hell is a crowbar? You've actually put like a crowbar in there? Now, crowbar is it's a very simple circuit that that acts very quickly to counter catastrophic things such as reversing the polarity of the input voltage or over voltaging the pedal. And there's lots of ways it can be done. Most pedals would have just a simple diode in line with the power input to prevent catastrophic failure if you flip the polarity. But even though that's a very simple and cheap way to do it, it does come at a sacrifice of the top voltage of better part of a volt. And one of the things that I really sought out in the early days of Frantone was to make sure that I could maintain the very highest operational voltage in the circuit, because a lot of my overdrives and fuzz tones and stuff, they really performed optimally when the supply voltage could be as close to 9 volts as possible. And so I wanted to make sure that my protection circuits wouldn't really impede that too much. So I use a simple two-component circuit. In the old days, I used a power resistor and a Zener diode configured in such a way that it would clamp, act as a crowbar and clamp if you flip the polarity around. And in the event of overvoltaging, power resistor would sink the excess voltage and it would drop it down to like 10 volts, between 10 and 11 volts within a safe margin if you plugged in like a 24 or 30 volt power supply. But often the crowbar would self-destruct. If someone had applied a high enough input voltage in the DC jack, or if they had left the polarity flipped around for too long, that crowbar could self-destruct and basically open up like a fuse. And so oftentimes I would get a pedal back because the crowbar had exploded, but it was by design, because the idea was to sacrifice that simple little circuit of components that I would mount off of the board on the power jack, and very easily to replace. Just pull them out and put a replacement in. I looked at it as a very easy workaround to save the circuit board and also to preserve the performance of the pedals. So it's a very common thing I have to do is replace that crowbar. But this one has seen some bad times. It looks as though someone has introduced a fluid into this pedal at some point. Let's take a look inside. So yeah, I took a quick look in here, and this has been serviced because the solder on the DC jack is not original. It's been resoldered, and this Zener is sort of the remnant of the one of my old crowbars, but it's probably shorted. And the 9-volt plug has been changed, because I always use these hard plastic cap types. They're just much more resilient. And also the strap that I put on the case here to hold down that is gone. And also I noticed corrosion. I don't know if it'll show up in the camera. The jack here, this is the input jack, and it's stained. The phenolic wafers are stained sort of dark black color, almost like oil. But the one tab here, it's all corroded and green, so it's been exposed to some kind of an acidic or alkaline compound, and the copper has started to leach out from the chrome, so this jack has to be replaced. And on the back plate, it's another stain here. This could be because someone sprayed, might have sprayed a contact cleaner into the switch. So yeah, I'm gonna test that. Switch might be fine. It just might have been, someone spraying some stuff in there, or whatever that other stuff was might have also got in the switch too. If it was bathed in a fluid like coffee, it's a very common kind of fluid for a pedal to get washed in. The board's all conformal coated and everything, so there's no sign of corrosion on the board. But I'm going to change out all these parts and give it a test. Yeah, that diode was cracked in half, so that was definitely no good. The socket is slightly melted, so the nuts won't come off when the socket is melted and distorted, so I've got a way around that. Sometimes requires a little persuasion. There we go. There we go. Ugh. Yeah, it's the only way to get a burned, melted jack out. Desoldered gun. I'm going to replace this altogether, so. Alright. Gotta have the right nut driver for the job. Makes it so much easier. Take a look at the jack. Yeah, oof. Yeah, look at, see, it's all corroded there. Turned all green, so yeah, that's, if that's a conductive material, getting saturated in those phenolic wafers, then you just got a resistive short. So just going to replace it. All right, here we go. So I got all of the damaged components out. I just start to refill and repopulate. It's harder to get that nut fastened after this block has been put in. I usually do that first, but it requires a special wrench. I put a little bevel there on the wrench. It allows me to get really close to the case and, get behind the nut. But yeah, this is one of my oldest custom tools for Frantone stuff. Indispensable. Great thing about universal standards, you can put a new jack in something that's, almost 20 years old, and it just works perfectly. Yep. Thank you, Industrial Revolution. So this little guy is the heart of my crowbar circuit. It's not a capacitor, it's a 10 ohm PTC, positive thermal coefficient thermistor. Basically it's a variable resistor. When it sinks some current, its resistance goes way up, and basically just acts like an open circuit. It's a lot easier to do this when it's being manufactured, because again that's like a pre-done assembly that's just dropped in, but doing this kind of surgical stuff to fit something in place after the fact, it's always a little more difficult. But that's the crowbar in place there. So it's got a 11 volt Zener for the voltage limiting if you're over voltaging, and then the PTC will act two different ways. So if you're over voltaging the pedal, that PTC is going to sink current, and the resistance of that goes way up, and basically the pedal just doesn't turn on. And then conversely, if you reverse the polarity, you're shorting out the Zener diode, and the again the PTC will sense that short, and its resistance will shoot up into tens of thousands of ohms. And again, it's sort of like a resettable circuit breaker is essentially how it acts, although there's no moving parts, it's just resistance. So it works pretty well. Really shaky today. Got the tremor going. Alright, that looks good. Here's a little trick. You want to get a tie wrap through a block, you just put a little bend on the end and it just goes right through. I've put many thousands of them in place. Alright. Got all the wiring in place, got the crowbar in place, LEDs hooked up, the new jacks installed. Alright, that looks good. One thing to do, to give it a test. Crowbar. Yeah. This is the voltage coming out of the crowbar, and you see this is why I use this circuit, 9.22 volts. So you don't have the loss of a diode drop if you just used a simple passive diode for reverse polarity, but you also get the added protection of over voltage protection, which you don't get just with a simple passive diode. So but there you go, 9.22 volts going in. Unfortunately, it looks like this pedal, in addition to having all that other stuff blown up, it looks like the board was over voltaged, and there's some damaged components. There's an op amp in there I think is probably toasted. Alright, basic troubleshooting time. Take a look at the power leg here. There's no shorts. Yeah, that's normal. So yeah, it's all normal. So it's not a matter of a short, but the op amp has probably just been fried. So yeah. Well, I clogged up my desoldering gun, and this is a little trick I learned when these get clogged because often what will happen is I'll turn it on, and when it gets to temperature I'll just use it and desolder some connections. But the problem is that even though the tip is at temperature, the tube is not really fully heated, and at the very, very top of the tube where it goes into the chamber, it's too cool, and so as you do some connections, the solder starts solidifying in the tube until you hit that last one, and then it just ends up being a brick of solid solder at the top. And so there's the only really way that you can get it unclogged is to do what I'm doing here, which is prop some stuff under the case to get it so that the gun is sitting vertical, completely vertical, and get it up to temperature. I got it at, we can't see it, 661 degrees Fahrenheit, and let it sit in this position, like with the gun completely vertical, for about 15 minutes, and the heat from the tip will propagate up through the tube, and after about 12 to 15 minutes, that temperature at the top of the tube will be hot enough to melt the solder block, and you just give it a little squeeze. Yeah, it's not quite ready yet. Well, my soldering and desoldering gun is clogged. I'm waiting for that to set up. All right. They were going to say, Fran, why don't you use sockets? You wouldn't have to do that. Well, I don't use sockets because it's bad to use sockets with audio stuff, anything analog. They do tend to fail, and as they get tarnished and corrode, you're going to have all kinds of performance problems if you use sockets with linear circuits. So I never do. Just put it right to the right on the board. I had a lot steadier hand 20 years ago, that's for sure. Okay. Alright, got the new op amp in there. The classic Fuzz. It's actually a transistorized effect using 2 MPSA-18s to actually create the effect, but uses an LM386 just as a current and signal boost into the tone circuit so that you can just get the right kind of amplitude on the output rather than having 2 more transistor stages. It made the board layout simpler, and it didn't affect the tone at all, but it just enhanced the performance. So yeah, it's a hybrid design, hybrid transistorized op amp. So yeah, let's give it a try. working good. Needs a little cleaning on the pots. Clean those off, a little spray, and it should be good to go. Lots of bass. Alright, yep. Low tone. Really a bass fuzz, but I use it for guitar too. Alright. It's working good. Yeah. So now that I've actually got the project done, now I can... Yep. And now it's open. So, yep. Only took like, half an hour to get it unclogged, but yeah. It's really the only way to do it with these things, but, isn't technology wonderful? I ended up using the old solder sucker. Still works, and you don't have to let this sit for half an hour. So much for technology. Yep. Now that I don't need it anymore, it's clean. Okay, this is ready to go back to its owner. Running as good as new. This is really why I started putting the crowbar in, because of these sorts of blow-ups, and kind of changed it over the years. Originally I just used like a 2-watt power resistor to sync that, but then I like the idea of it being resettable, and so ever since these last runs I've been using the PTC, and I'm really a big fan of the thermistors for doing this sort of job. But from now on, it'll be protected, so if somebody flips the polarity or over voltages it, it won't blow up again. So, yeah, making it more bulletproof. Okay, all right, that's it. Basic repair. Although this one was blown up pretty good all around. Thanks for watching. Thanks too to all of the patrons there on that there Patreon, making all these videos possible. Thank you. Yep, it's true. The only reason I'm doing FranLab and making these videos is because of all of the people who support this channel on Patreon. If you like these videos, if you like what I do, then consider becoming a patron. It's real easy to do. You just follow the link in the description, become a patron, and I will continue to do this into the future. Okay. I'm Fran. I'll see you around real soon. Bye! Berserk. In my lab, it's where I work. That's what you're watching. FranLab. That's what I'm doing. Working at the bench again.